All right, so we're really thinking about slope, and slope is defined in a bunch of different ways, and I really want to make sure that you see all of them, just because these are some of the most common ways to describe them. And you've probably seen it as rise over run, and so I put that last so that it's still familiar to you. But I really want you to start thinking about it in terms of like the rise of something is really the change in the y value, and the run is really the change in the x value. So we can think about it as change in the y value divided by the change in the x value, or it's called the rate of change. And so these three are kind of the golden ticket of how we actually work with slope in different situations. So I really want to kind of define, there's two pieces to any equation that's a line. And we're thinking about a line in the form y equals mx plus b, and the b value is the y-intercept. So we're thinking about the b value in this particular slide, but I just want you to be aware that, you know, we've got this b thing. So we're thinking about the starting point, and if you get a table of values, and we want to think about this table of values, is we've got the input, or the x value, and the output, which is the y value, and that's always true. So the x is this x, and this y is this y. So what I'm saying is that if the x value is here, and if we knew m and b, if the x value is -2, and I ran the numbers, I'd get 10 out. If I plug -1 in for x, and I did some math, if I knew m and b, I'd get 9, and so on and so forth. And I want to think about this starting point. The starting point is the output value when the x value is 0. That's the y-intercept. So in both of these, I want to think, okay, the x value is 0, is right here, and so the starting point, or the y-intercept, is this y value. So for this particular problem, the y-intercept is 0, 8. And in the second one, go ahead and think for a sec. What is the y-intercept? What is the output when the x value is 0? And hopefully you chose 0, 10. So the y-intercept is 0, 10. And we'll use this in just a moment. So we've got this y equals mx plus b thing, and we're thinking about slope, or rate of change, and how things grow or change. And we're also thinking about starting point, or the number in when x equals 0. Now, in this particular graph, I hope that you see that we're starting with 1, and then 2, and then 3, and then 4. And I'm starting to notice that each time the pile grows by 1, so if going from 1 to 2, or 2 to 3, it looks like it's increasing by 2 each time. So the rate of change here is 2, and we'll talk a little bit more about that from a table view in just a moment. And it's really hard to find the start, because really I'm interested in when it's 0, but I know that if it's going up by 2 each time, if it went backwards, it would be -2. So really there are -2 blocks, which is my starting point. This is my starting point, is -2. Well, if I were to do this with a table, I'd think for just a moment, if I have an x as an input and a y as an output, I'd think, okay, I'm gonna want 0 eventually, but I got 1, and then 2, and then 3, and we could keep going, but I think this will get the point. For pile number 1, there's 1 block. For pile number 2, there's 1, 2, 3 blocks, so 3 blocks. In pile number 3, there's 1, 2, 3, 4, 5 blocks. So notice, I hope that you see here that, remember, if we're thinking about the slope, the m value, as the change in y over the change in x, I'm thinking, okay, this increases by 2, the change in y is 2, and the change in x is 1. So the rate of change, the m value, is the change in y is 2, the change in x is 1. And so to simplify, that's 2. And that's where that 2 came from. And to go backwards, I would have to go back by 2, so I get negative. Oh, excuse me, -1. I was wrong up here. Oh goodness, that should be a -1, and I can't erase it for some reason right now, so I'm just going to put a big old -1 there. -1 is what it should be. -1, my bad. Okay, so the rate of change, core idea here is the slope, the m value, is the change in y over the change in x, and if I look at a table, I've made this table by inspecting this visual, it's the change in the y value divided by the change in the x value, and that's right here. Okay, we're going to do a couple more of these, so if you're a little bit unsure right now, that's okay. Just take a moment to inspect this. All right, so remember, we're thinking about slope, and slope is m, but we also know it to be the change in the y over the change in the x. Change in y divided by the change in x. And now I'm going to do this in the table. I want to think, okay, the change in y is it's increasing by 3, it's increasing by 3, it's increasing by 3. That's really predictable. So the change in y here is plus 3, or just 3. And now I've got to look at the change in x. So what's x going by? Well, this first one, it's really going up 2 plus 2 each time. And I got to look at just a single one of them. I'm going to just look at a single one. In fact, I don't like that one. I'm going to pick this other one. And I'm going to look, and I'm going to say, okay, the change in y was 3, but the change in x was 2. So my slope here is 3 over 2. I'm going to do that in red because that's going to be the color that I'm interested in. And remember, our y-intercept is the starting point where the x value is 0. And so I see that right here. The x value is 0, the y value is 6. The starting point is y equals 6, or the starting point is 6. I'll just put 6 there for ease. Well, when we go to our equation, y equals mx plus b, well, our m is our slope. So I'm going to replace the m with our slope, and it was 3 over 2, x plus, and our starting point was 6. So I can start writing an equation for this. Now check this out. Anytime I want to find out what's the y value, I can plug it in. So check it out. I'm going to test it. Does my equation work for an x value of 10? Well, I'm going to substitute x in for 10. So y equals 3 over 2 times 10 plus 6. Well, that's 15 plus 6, or 21. Good, that checks out, because I end up being 21. Core idea here, the slope is the change in y divided by the change in the x. The change in the y values divided by the change in the x values to get our slope. And we can find the starting point pretty easily too. All right, this one's a little bit more tricky because it has less information. And I want to look at all the things that I have complete. So I have complete here. I know this x and this y, so I'm going to use this one for sure. And I have this one is complete here, and I'm going to use this one for sure. And I could use this one, but I'm not for right now. If we had more time, we would do it as well. So I'm thinking about the slope. The slope is the m. The slope is the change in the y value divided by the change in the x value. And I can only do this between points I know. So the change in the y value from 7 to 15 is up by 8. So 7 plus 8 is 15. And so my change in my y value is 8. And the change in the x value goes from 1 to 3 with the same points. I can't choose different points because that's not fair. And it goes up by 2. So my change in my x for those same points is plus 2. Well, this is a proportion or a ratio that can be simplified to 4 over 1. So if it's easier to use the change in y being 4, then the change in x is 1. So if I kind of go back to my equation, if I go back, I think, oh, hey, this is really, I'm going to change it to be a color that I like. This was a plus 4, which means if the change in y is plus 4, the change in x is plus 1 now, because I'm using this equivalent slope. So what was before 1? It was 0. And actually, that's really handy, because when x is 0, that's my starting point. Well, using this information, if I increase my x by 1, change in x, change in x, then my change in y is 4. My change in y is 4. So here, from 1 to 2, so if I go plus 1, so 2, then take a look. 7 plus 4 is 11. And again, plus 1 is plus 4 in the y area. And I could continue to fill out the rest of this table based on this, but we really want to get to the equation. Remember your template, y equals mx plus b, where the m is your slope. So the m, I'm going to replace the m with the 4 over 1, or I guess you could just say 4x plus b. The b is 3. So this is my equation, and I could substitute values. So we're looking for an equation from a table, and the way we have to do that is to consider the slope is the change in y over the change in x. So I have to know what x and y are, and I can find the slope, and then when I find the x value being 0, that's the y value is my starting point. So that's where I got that 3 from, and I can just plug in the slope and the y-intercept, and I'm done. Well, here's a problem where I'm given 2 points, and really I just want to put some visualization to this. So if I'm connecting these points with a line, I can do that. And in class we talked a little bit about a slope triangle. And really what a slope triangle is our rise over run. So if I'm going from a height of 3 to a height of 11, that's an increase of 8, right? It's increasing by 8. 1, 2, 3, 4, 5, 6, 7, 8. And if I'm going from 1 to 5, that's an increase of 4. So really I'm making this slope triangle. Here's where that 1 and 4 come into a table. So x is 1, y is 3, so that's our first point. And our second point being 5, 11, 5 is the x-coordinate, 11 is the y-coordinate. I can think about the change in y over the change in x by looking at the y value. So the change in y from 3 to 11 is plus 8. So my change in y is plus 8. And my change in x is plus 4. So my change in x is 4. So my rise over run here is 8 over 4, or you could reduce that fraction to 2 over 1 or just be 2. So the goal here is you can create a table based simply on points that you pick or points on a graph, and I can use that to use the change in y over the change in x to find the slope, which is also used the rise over the run. So I hope this video was informative on how to find the slope from a table of values. All it is change in y over change in x, and we can use that information to calculate an equation. Thanks for watching.